Imagine this. We use electricity every day. It powers our phones, computers, and lights up our homes. But where does it come from? Some of it might come from huge power plants where atomic reactors are at work. Sounds like something out of a sci-fi movie, right? But it's reality, and its story is a true detective tale with elements of scientific breakthrough. Step 1. When scientists became atom detectives a long time ago, at the beginning of the 20th century, scientists started unraveling a huge mystery. What's inside an atom? They already knew that atoms are tiny building blocks that make up everything around us. But it turned out these building blocks weren't so simple after all. Marie and P'yer Kюrі, these two science superheroes, discovered that some atoms, like radium, don't just sit still. They constantly shoot out something from themselves. They called this radioactivity. Imagine an atom as a tiny volcano, constantly erupting invisible particles and energy. Ernest Rezerford. This scientist was like Sherlock Holmes for atoms. He figured out that an atom has a tiny but very dense nucleus at its center, with electrons spinning around it. And he even managed to break apart the first nucleus. It was like taking a huge rock and smashing it into pieces, but on an atomic level. Альберта Ейнштейн! You've definitely heard of him. Einstein gave us the famous formula, E equals MC2. It's not just a bunch of letters and numbers. It means that even a tiny particle of matter can contain a simply enormous amount of energy. It was like discovering that a single crumb of bread holds enough energy to light up an entire city. Step 2. Whoop. The atom split. A real breakthrough happened in the late 1930s. In Germany, two scientists, Otto Hahn and Fritz Strassmann, were doing strange experiments with uranium, a very heavy metal. They were bombarding it with tiny particles called neutrons. And what happened? To their surprise, the uranium didn't just change. It split in half. Imagine throwing a tennis ball at a huge watermelon, and it shatters into pieces. They called this nuclear fission. But the most interesting part was discovered by Lisa Meitner and Otto Frisch. They explained that when a uranium nucleus splits, it not only releases a ton of energy, but it also shoots out several new neutrons. And that's where things got really exciting. Step 3. The chain reaction. An atomic domino effect. Imagine that every new neutron that flies out of an atom then hits another uranium atom, causes a split as well. And that atom in turn releases new neutrons, which hit the next atom. It's like a huge domino effect. One atom starts a reaction, and it keeps going, all by itself. This is called a chain reaction. One clever man, Leo Szilard, realized if we could control this chain reaction, we could get a huge amount of energy. But if we didn't control it well, that would be something very, very explosive. Step 4. The first atomic heart. Chicago, Pile 1. So, scientists understood they needed to build a machine that could control this chain reaction. The main engineer and conductor of this project was Enrico Fermi. He was a true genius who knew how to turn theory into reality. In 1942, during World War II, Fermi and his team built a strange house under a football stadium in Chicago. It was made of uranium blocks and graphite. They called it the Chicago Pile. Pile meant heap because it really did look like a heap of blocks. December 2nd, 1942. This day became historic. The scientists slowly pulled out special control rods. And then, at 3:25 p.m., the instruments showed the chain reaction had begun. The atomic heart was beating. For the first time in history, people had initiated a controlled nuclear reaction. This was a huge step. It wasn't just a scientific experiment. It was the dawn of a new era. What's next? After Chicago Pi 1, the era of atomic energy began. Initially, it was used to create atomic bombs. But then people realized that this gigantic energy could be used for peace power plants. Atomic reactors generate electricity for millions of homes worldwide. They're like artificial suns that produce energy without burning coal or gas. Medicine. Atoms help doctors diagnose diseases and treat cancer. Research. Scientists use atomic reactors to study materials and create new technologies. Of course, atomic energy is a powerful force, and it must be handled with great care. But thanks to the genius and bravery of scientists like the Curies, Einstein, Szilard, Fermi, and many others, we were able to unravel the mystery of the atom and harness the immense energy contained within its tiny heart. It's truly a fascinating adventure, isn't it?